have to do that, and sometimes you might not be able to do that, but generally you can take the equation and literally cut it in half and look at it as two different parts. So grouping, you're pulling terms together. That's what grouping means. Pair things together, pair three terms, or group three terms together. So if you have a 3a minus 5b, Brenton, what would you factor out there? Say again? Only a 1, yeah, because they only have a 1 in common. They're not divisible by anything else. So I'm just going to place a 1 in front. Brenton, how about the second pair? What could we factor out there? Yeah, we could take out a 2c. It's a positive 2c. Make sure you have a plus sign there. If you don't, you've taken an expression that has addition, and now you've changed it into multiplication, and it can't be multiplication yet because we haven't got to that multiplication part. Brenton, what goes in the parentheses if you take out a 2c? So what condition must be met in order for grouping to work? What has to happen? The what? Least common denominator. What else has to happen with grouping to work? Somebody else. Somebody say. The parentheses have to be the same. If they're not the same, then you cannot finish the grouping part to actually make it a factored problem. Factored means write as a multiplication problem. So if you have parentheses that are not the same, then you didn't group together correctly, or maybe it couldn't be grouped together at all. But if they are the same, then you can pull the terms in front together in a set of parentheses. And the reason you can do that is because they're being multiplied by the same parentheses, so they're like terms. And then we have that 3a minus 5b. So factoring means take an expression that was expanded and put it into a multiplication problem. That's what factoring truly is, writing it as multiplication. Questions? So looking at number 2, 6x plus 3y minus 12ax minus 6ay. Factor by grouping. So 4 terms is when you're just using grouping. There's no AC method because it's not a trinomial. So Nick, what could you take out here?
The first one, you can take out 3.
Take out a 3, and you're left with?
X and Y.
How about a 2 with the x?
Yes.
Yes.
The 2x.
Okay.
Plus Y.
And then the second?
You could also, you could take out a 6 actually.
Yeah,
Negative
6 and?
And a.
And an A. It is an A.
Okay, yeah.
Mm-hmm. And then what do you have?
Left with 2x plus 1.
Good. So we have 3 minus 6a and 2x plus what? Does it look okay? Is it completely factored? The answer is no.
It's not. Come on, guys. The 3 and the 6. Are you kidding me?
Are you kidding me? Josh, what's wrong with the 3 and the 6?
Pull out a 3.
We could pull out a 3,
1 minus 2a.
and then that would be 1 minus 2a.
Amateurs.
What's that called, Josh? The
Pulling
3.
out.
Pulling out, GCF? You could do it at the beginning in the first step.
No.
Is there a GCF?
Yes.
If you don't, that's okay. Make sure you don't move to the next problem before checking to see if everything is factored completely. So looking at number 3, what could you do first with number 3? What do they all have in common? An x.
Correct.
So pull out an x first, and now we have x cubed, x squared, x, and then 1. So a GCF really could be taken out whenever. Generally, we try and take it out at the first step, because then you don't forget about it. But you could take it out when you're done factoring as well. Just make sure you look to see, is it factored completely? And then placing a little line down the middle, Carrie, what can we take out of the first pair there? The second pair, just a 1. And then what does that look like, Carrie? Just x plus 1, because these are being pulled together in the same group. What else? The x in front, because we factored out a GCF, so it comes down.
There you go.
So we have the x. We have the x squared plus 1. Those were the 2 pieces we pulled out, and then we grouped the like term, the like parenthesis, together as 1 as well. Is everything factored completely? Does the x squared plus 1 get factored any further? No, because it's a plus. sum of perfect squares. So it's factored completely. So GCF was the x. We put out an x squared and a plus 1, and then in parentheses was the x plus 1. And again, once you're condensing and grouping them together, you just have that one set of parentheses. The x plus 1 is just 1. So the last one here is a 6-term expression. You can do this a couple of different ways. You could group pairs together. So you could say, I'm going to group the first 2, the middle 2, and the last 2. You can group 3 of them together, and you could say, hey, I'd rather look at the first 3 and the last 3. It's up to you. You're going to get the same answer. It just depends on what you notice about the problem. So, Hannah, how would you like to factor it? What'd you do? So you did 3 separate ones. And what did you pull out of the first pair? So 2x squared, and then inside you get? How about the second pair? And you also get? And then the last pair? Yeah, it's just x minus a. Right here. Thanks. She said A, I was writing 1. Not sure why. So now you have 3 sets of parentheses that must be the same. If one of them is different, then you didn't pull out the GCF correctly. You can pull together the 3 terms in front in one big parenthesis. So we have 2x squared plus x plus 1. And then those 3 parentheses that were each separately being added with the coefficients in front now pull together. And together now it's being multiplied still with those coefficients in front. If you factor it the other way and you say, hey, I'd rather look at 3 terms together, then you're going to have them flipped. So you would have the x minus a first, and then you'd have the 2x squared plus x plus 1 second. You get the same answer, but you just have 2 terms in front because you're only factoring it as 2 groups. Questions? Does this guy back here, 2x squared plus x plus 1, does that factor? No, but don't forget to check.
I can teach.
Oh, you sure?
If you need to take
Yeah.
it,
No, I don't. It's a random Harrisburg number.
call the coronavirus.
Maybe. Yeah.
We're gonna get
Any questions with the factoring grouping? AC group or traditional grouping. All right. So the other type of factoring that we're going to give you a little refresher goes back to chapter 5 last year when you did polynomials and you learned about the SOAP pattern. So sum and difference of cubes.
Opposite, always positive.
Nice. So we have the same, the opposite. I can't write diagonal. Let's try the other way. So S represents the same sign. O represents the opposite sign. And then, as Carrie said, A and P mean it's always positive at the end. So SOAP represents the signs in the middle that divide up your terms. So the same sign is what you started with. And then the opposite sign, and then both of them are always plus, always positive. The pattern is AB, A squared, AB, B squared. AB, A, B, A squared, AB, B squared. You just have to figure out what A and B are. So they have to be cubes, number 1. This is the cube formula, sum and difference. So if you look at x cubed minus 27, is 27 a perfect cube? Yes, it is. So you need to take the cube root of each of those because that's actually what your A and B represent. Josh, what is the cube root of x?
Sorry.
What is the cube root of x cubed?
X.
And the cube root of 27 is?
3.
So the A term is just x, the B term is just 3. And then you're plugging them into the pattern. So it says take A, same sign, B. So A, same sign, B. And then A squared, opposite sign, A times B, just taking those two things, multiplying them together. Always positive, and then B squared. So A, same sign, B. A squared, opposite, AB, always positive, B squared. And then you're done. This last term here will be prime. Prime is when something can't be factored any further. A number is prime because 1 and itself is the only divisors or limit factors. An expression is prime because you can't break it down any further. There aren't two numbers that multiply to be 9 that will ever combine to be 3. It'll always be prime. So if you look at number 2, ask yourself first before you factor it, is there a GCF?
Yes.
There is. Even though those numbers are perfect cubes, still you got to take a GCF out. So Colin, what would the GCF be of number 2 that we can pull out?
8.
An 8. So let's take out an 8, and then Colin, you end up getting
Is it 2y? Or will you be 8y is cubed plus 2.
plus
1.
1. So if you pull out an 8, you're left with 8y cubed plus 1. So there is a GCF. The second step, are they perfect cubes? Yes. 2 times 2 times 2 makes 8. 1 is a perfect cube because 1 cubed is still 1. So your A term is 2y. The B term is just 1. So the cube root of 8 is 2. The cube root of y cubed is y. So the cube root of 8y cubed is 2y. The cube root of 1 is just 1. Lauren, how does that look then if you're factoring it using the pattern? So A, same sign, B. And you're so close. This is going to be a minus. So when you square A, it's A squared. You need to square both the 2 and the y. So this whole thing is squared. That's why it's 4y squared. Multiplying A times B, but it's the opposite sign. Always a plus, and then 1 squared. So looking at the pattern there, A, same sign, B. A squared, opposite, A, B, always positive, B squared.
Period.
So number 3, is there a GCF? 27 and 125. No. Carrie, are they perfect cubes? Yes. What is the cube root of 27? And the cube root of 125 is 5. It's okay that there are two variables there. You just have a variable in the front and a variable in the back. So 3x and 5y are your A and B terms. Carrie, how was that factoring them? Thanks. So again, here's A, B, A squared, AB, B squared. Your same sign, opposite sign, always a plus. So that's why it's a minus first, because that was the same. Questions? Reese, how about number 4? What's the GCF of number 4? And if you take a 2x out, what do you have? And then how did you factor it? So the cube root of x cubed is, and the cube root of 8 is, and then how does that look? Nice. Questions? So GCF first, 2x. And then the cube root of x cubed is an x, the cube root of 8 is 2, and then using the formula. So the last one, throwing in a large power here. Going with y to the 9, or x to the 9, no it is y to the 9 plus 1. What is the cube root of y to the 9th? Y to the 3rd. So y cubed times y cubed times y cubed makes y to the 9th. Because 3 plus 3 plus 3 is 9. And then the b term is just a 1. Cube root of 1 is 1. So when you go to factor this, we have a, which is y cubed. Same sign, b. And then you have a squared. What is a squared? What does that become? Garrett, what's a squared become? So if you have y cubed and you square that, what does that become? Y to the 6. So y cubed, if you're squaring that, you're multiplying that exponent, or you're really taking y cubed and y cubed together. And then it says opposite sign, a times b, so that's a y cubed times 1. And then always plus and b squared. Is this completely factored? Why not, Carrie? Yeah, this guy right here is still y cubed plus 1. It's still y cubed. And if it's still y cubed plus 1, it's still a sum of perfect cubes. So now the a term is just y, because the cube root of y cubed is just y. And the b term is still 1. This back part does not factor any further. It will always be prime. So you can just write that back part a second time. But the front part is factored one more step. A, same sign b, a squared, opposite, a times b, always plus, and then b squared. Make sure things are factored completely. Questions? So if you flip the page, they're wonderful factoring problems. On the front and the back, I believe.
Yeah, no, it's page 11 page.
It's not 10 and yeah. All right, so pages 11 and 12. I guess I need to change that. Page 11, you're doing just the odds, unless you'd like to do all of them. So 1 to 21 odd, which is the left column. And then on the back, it goes up to 27, and again, you're going to do the odds. So pages 11 and 12 instead of 9 and 10. So just do the odds. I will post the solutions. Make sure it's completely factored. So anybody interested in doing 17? Josh?
Yeah.
And then 19 and 27 are like, you do both of them. Hannah? No. Oh, Hannah, you're good. You got 3.
Yeah, no, Anna. Let someone else get it.
Or you let somebody else do it.
Save it.
Lauren, you want to do it? And Josh, you have
Oh, yeah, I got it.
17.
Yep, don't worry. It's
could be wrong.
So tomorrow, beginning of class,